Hello students, in this today's class or video we are going to learn chemical properties of carboxylic acids, and in this part first one we are going to have A, which is dealing with reactions due to hydrogen atom of carboxylic acids, right? And these reactions will reveal that the carboxylic acids are acidic in nature. Under this A we are having the first reaction, that is a reaction of carboxylic acids with active metals. The carboxylic acids will evolve hydrogen gas when treated with active metals. Active metals are those which easily undergo oxidation, and that of which undergoes easily oxidation, that is loss of electrons, right? Their E0 values will be what? Always negative. One has to remember that, right? And the active metals whose E0 value is negative are those of typically called as sodium or potassium, calcium or magnesium, or that of what? Zinc. So let us have one example. I'll be taking acetic acid as an example. Acetic acid, when treated with active metal sodium, it gives sodium acetate, right, along with the evolution of hydrogen gas. Now since hydrogen here it is water 2 times, right, but here hydrogen is only what? 1 time. So let me write it as water 2 times here. Now if I write here 2, the whole carboxylic group, okay, this part becomes how many times? 2 times. So therefore I have to write on the right hand side as what? 2 times. Fine. And when I write here 2 times, this sodium becomes how many times? 2 times, isn't it? So therefore let me write here also what? 2 times. The reaction is now balanced. So here one has to remember to write the name of this reactant. So here we have written acetic acid, and here the product is what? Sodium acetate. Is it clear, students? And I have just now told you that since we are learning, okay, the reaction due to what? This hydrogen atom of carboxylic acid, right? So therefore it means that we are going to cleave here, okay? It means that it is the reaction due to cleavage of OH group of carboxylic acid. One has to understand that it is because of what? Cleavage of what? OH group of what? Carboxylic acid. Now the second reaction we are going to study is reaction with hydroxides. Carboxylic acids are going to react with hydroxides to form salt and water, and it is a simple reaction called as neutralization reaction. We know that carboxylic acids are acids and hydroxides are nothing but base. Acid and base react together to form salt and water, which is simply called as neutralization reaction. Let us take a simple example of acetic acid here. CH3 C double bond O OH, right, plus when treated with sodium hydroxide, that is NaOH. We already know that NaOH is a base and this is an acid, right? If it is an acid, we know that these bonding electrons are taken by this, it provides H plus, right? So this will be coming outside in the form of what? In the form of H plus, and anyhow sodium hydroxide is furnishing OH minus, so this becomes OH minus, and here we are getting what? Na plus. So therefore we will be getting CH3 C double bond O, then followed by O minus, Na plus, plus we are getting here water. So this is nothing but called as a salt. It is simply called as this is called as salt. It is simply called as sodium acetate. Sodium acetate, right? So it is a simple neutralization reaction. Acid is going to react with the base, formation of salt and water. Let me have another example so that it will be much more clearer. We will take an aromatic carboxylic acid, that is benzoic acid, C6H5, C double bond O, then followed by OH, right? So this is called as benzoic acid. So this benzoic acid, when we treat with sodium hydroxide, or even you can treat with water, potassium hydroxide, right? So this becomes what? A base. And we already know that we'll be having one salt of that carboxylic acid, C6H5, C double bond O minus, then followed by Na plus, along with the formation of water. And this compound is called as sodium benzoate. Is it clear, students? Let me take an example of formic acid also. Okay, so formic acid, HC double bond OH. So this is formic acid. Formic acid when treated with the base such as ammonium hydroxide. Okay, and we will be having C double bond O minus, then followed by NH4 plus. Along with that we will be having water molecule, and this compound is called as ammonium formate. Is it clear, students? Now in the third reaction, that is a reaction with carbonates and bicarbonates. Okay, that is the reaction of carboxylic acids with the carbonates and bicarbonates. Carboxylic acids are going to evolve carbon dioxide, that is CO2 gas, right? And this evolution of CO2 is accompanied by brisk effervescence. Brisk effervescence means we can see in a test tube when we take carboxylic acid, and when we treat it with the aqueous solution of metal carbonates, we can see the bubbles rising. That bubbles rising is nothing but called as what? Brisk effervescence. Let us have one example with a simple example, that is by taking acetic acid, right? So acetic acid formula we already know it, CH3C double bond OH. When it is treated with metal carbonate like sodium carbonate, it is also called as washing soda, right? Then we will be having here corresponding salt of that carboxylic acid, and that becomes sodium acetate, along with the formation of water, that is H2O, along with that of water, CO2. In the sodium carbonate, that is on left hand side, here we are having it as water 2. I hope you are able to see, right? But in the product side, sodium is only one time, so we have to write here water 2 times. By writing here 2 times, the carboxylic acid on the left hand side has to be balanced in such a way such that it also has to be written 2 times, right? And now if we calculate the number of carbon atoms and sodium and even the oxygen atoms, all are water balanced. Now let us have one more example by taking benzoic acid. Benzoic acid formula is C6H5, C double bond O, then followed by OH, and let us treat it with metal bicarbonate. That is an example of sodium bicarbonate, NaHCO3, which is also called as baking soda, right? And we will be having a salt of that acid, C6H5, C double bond O minus, Na plus, along with the formation of water, H2O plus CO2. And in this reaction, Na on the reactant side, here there is only one time, and therefore on the product side also it is only one time, so the reaction is balanced here. All you have to just write here the name of this compound. So this is benzoic acid, and here it is sodium benzoate, Now students, we have to remember one important point, that now this reaction, that is a reaction with the carbonates and bicarbonates, where a carboxylic acid is going to evolve this carbon dioxide gas in the form of what, a brisk effervescence, right? So this reaction is used to detect for the presence of a carboxylic group under investigation. So if the invigilator has given you a corresponding carboxylic acid, and if he ask you how do you find for the presence of carboxylic acid carboxylic group, then all you have to add is just water, a little bit of sodium carbonate or sodium bicarbonate. A brisk effervescence can be seen, thus we can say that the compound is containing a carboxylic group, right? And since carboxylic acids are acidic in nature, they will be turning the blue litmus paper red. Okay, that also one of the physical test can be done and confirmed. Now we are having the B, okay, A, that is because of a hydrogen atom of carboxylic group. Now we are going to learn the B part, that is a reaction due to OH part of a carboxylic group, right? And one has to remember a very important note here, and that is in these reaction the OH part of this carboxylic group, okay, this OH part, right, is going to participate in a lot of reactions, and it will be leading to a number of products which are simply called as acid derivatives, So here we are having the first reaction, and that first reaction is nothing but a formation of esters, which is called as esterification, right? Carboxylic acids are going to react with alcohols in the presence of an acid catalyst to form an ester, and the reaction is called as esterification. And one has to remember that these esters are always having a fruity odor, right? So when an unknown compound is given for you, and if the person, okay, that is nothing but the invigilator, if at all he has asked you to add an alcohol to that compound and just tell me what is the compound under investigation. So if it is giving a fruity odor means, then your answer should be that the compound under investigation is nothing but carboxylic acids. So let me write here an example. Okay, before that example, let me have a general reaction. Okay, GR. Okay, the GR stands for general reaction. Okay, I'll be taking an carboxylic acid, R, C double bond O, then followed by water, OH. Okay, so this is simply called as carboxylic acid, and let me treat it with an alcohol. Okay, so I'll be writing in reverse manner so that it will be easy for we people to understand, as well as the reaction representation also, right? So this will be under equilibrium. Okay, so rate of forward reaction is equal to that of backward reaction, but here we have to carry in the presence of an acid catalyst. Okay, right? So we know that we are speaking of cleavage of what, OH group, right? So here I have written there in this reaction OH part of C double bond O and OH. Okay, this part, okay, where I'm encircling here, that is going to be cleaved. So therefore what we can recall that we are going to cleave this OH part here, right? So this OH part is cleaved, and we are going to cleave here hydrogen of this what, OH. So what is lost actually? Water is lost actually, right? So therefore I can write it now as R, C double bond O, then followed by O, then followed by R. Okay, so in order to distinguish which R is where, so I'll put here one R dash. So this becomes the alkyl group of alcohol. So therefore I will be writing here R dash, right, along with the formation of water, H2O, right? So this compound is nothing but called as ester. Fine. And esters in IUPAC terminology are called as alkyl alkanoate, ALKANOATE. Fine. And one has to remember that this alkyl group is nothing but this now. Okay, this is called as alkyl, and the remaining part, that is C double bond O and O, is called as alkanoate part. Fine. Now let us have one example. So here let me take acetic acid. Simple examples we are supposed to take, students, right? So that it won't lead us to what, confusion. Acetic acid along with an alcohol, that is methyl alcohol. equilibrium condition reactions in the presence of what? H plus, and we know that we have to cleave this OH part of carboxylic group and the hydrogen of this what? Alcohol. So just you have to what? Remove this in the form of what? H2O, and here we'll be having our ester, which will be having fruity odor, CH3, C double bond O, then followed by O, CH3 plus water, that is H2O, and the name of this ester is, so this part we have to write here first. So this is nothing but called as methyl, right? And the remaining part is nothing but acetate, so therefore it is called as methyl acetate. So here this is acetic acid, and this compound which is called as alcohol, it is having a name called as methyl alcohol, or we can call it as methanol also. Now let us have with another example by taking aromatic carboxylic acid, that is benzoic acid, C6H5 C double bond O OH, right? Let us treat with again methanol itself only, OH, then followed by CH3 in the presence of acid catalyst where the reaction is under equilibrium, and we have to cleave this OH part of this carboxylic group and the hydrogen of this alcoholic group, right? And this will be eliminated in the form of water, and we are going to write our product C6H5 C double bond O OCH3 along with the formation of H2O and our compound. So this part we have to write first, so that is methyl, and this remaining part is nothing but called as benzoate. This is benzoic acid, and here this part is methanol. Now students, we have learnt the esterification, but there are two important notes for us to understand here. Note number 1. In this note number 1, we have to understand the reactivity of a carboxylic acid towards esterification. I have written the order here. In the order you can see that formic acid is going to react in a greater efficient manner, okay, when compared with what? Acetic acid, right? And this acetic acid is much more reactive when we compare it with what? The previous one, that I'll write it here, this has what? Number 3 here, right? Because here the alpha carbon atom, this is the alpha carbon atom, it is substituted by one more alkyl group here, so therefore it is showing less reactivity, okay? So let this become 2 and this become as what? 1, okay? In the fourth one we can see that the alpha carbon atom is disubstituted by what? 2 alkyl groups, okay? And in the fifth one we can see that the alpha carbon atom is having 3 alkyl groups, okay? So with increase in the alkyl groups, steric hindrance increases, and because of this steric hindrance, reactivity of the carboxylic acid towards esterification goes on what? Decreases. And the same thing is true even for this alcohol also. Let me write this as 1, this as 2, this as 3, and here we are having the fourth one, right? So methyl alcohol is very much reactive towards what? Esterification, as that of which compared with the substituted alkyl group for this what? Carbon atom, right? And similarly if you see the third one, here we are having 2 alkyl groups, okay? Steric hindrance is going on increasing, and in the fourth one we can see that there are 3 alkyl group on the carbon atom bearing what? OH group, okay? So as steric hindrance increases, reactivity of alcohols also towards esterification goes on decreases. So one should remember, okay, I forgot to mention that which is alpha carbon atom in carboxylic acid, okay? That is the carbon atom adjacent to this functional group, okay? This is the functional group which I have encircled, okay? So this carbon is called as the carbon which is in red color, okay? Here that is called as alpha carbon atom. Now we have to learn this mechanism of esterification, right? So let us write first the carboxylic acid, R double bond O, then followed by OH. Okay, that is a carboxylic acid. When it is treated with H plus, and the reaction will be under equilibrium, right? So one has to remember that. Okay, the lone pair of electrons which are present on carbonyl group are going to attack this H plus. So we get what? A protonated carbonyl group now, right? So here oxygen becomes positively charged because oxygen is a divalent, but here oxygen is linked with 3 bonds, and the remaining part, that is what OH as it is. Now the intermediate, okay, this I call it as the first intermediate here. Okay, so in order to balance that positive charge, what this pi bond will be migrating to this oxygen atom, so that it has to be compensated. So therefore we can write one more intermediate, that is R single bond C, then single bond OH, right? And again here single bond OH, right? And because of that migration of that pi bond to that positively charged oxygen atom, now the positive charge is present on this carbon atom. Fine. Now the attack of the alcohol molecule takes place. So under equilibrium conditions, I'll be writing in this manner, right? So that alcohol ROH, okay, one should remember that alcohols are versatile compounds. They are acting as a nucleophile as well as what a electrophile. Now here we are having a positive charge on carbon atom, so therefore the lone pair of electrons are coming and attacking to this positively charged carbon atom. So therefore the next part I can write it as RC, then followed by OH part here, and here also I can write it as what OH part. Here it is bearing 2 lone pair of electrons, and now whatever that alcohol has attacked, that part I am going to write here now, single bond O, right? And then followed by what H, and then followed by what R. Okay, that is alcohol. But in this alcohol we can see that the oxygen atom is now, it has become a trivalent, so therefore I have to write it with positive charge. And in order to compensate that positive charge, in the sense it has to be removed, so here what happens, these bonding electrons are moving towards this oxygen atom. Then what happens, this H is expelled in the form of what H plus, right? And this H plus is now taken by this lone pair of electrons. So therefore I can write one more intermediate here. So here I can write it as what R, right? Then followed by C, then followed by what OH, and here I can write it as what OH2 and a positive charge, right? Because it has taken one H plus, and here what we can write single bond O, and I can write it as what just R. Okay, so in order to differentiate that alcoholic R group, okay, that alcoholic R group, okay, which I have to write in form of what a red color. Okay, so I'll write here what R, right? Fine. So here also let me write it in the form of what red color, that is R single bond O, then followed by what H. Fine. Now one more change I have to make here, that is nothing but this hydrogen. Okay, so let me write in the form of single bond. Okay, so here I'll write it as a single bond and H, and in this intermediate the lone pair of electrons which are present on oxygen atom, okay, they are going to form a bond between this carbon and this oxygen. So therefore this carbon becomes pentavalent. Actually carbon valence is 4, so if carbon valence is 5, it becomes highly unstable. Under this condition this part will be going outside in the form of H2, that is loss of water molecule. Okay, so therefore in the forward reaction what happens, there will be water loss of water molecule. I'll be writing it as minus H2, and under backward condition the reaction will be happening in the same manner, right? So the remaining part I can now write here as R, right? Then followed by C, then followed by a double bond, then followed by O and a hydrogen. Since there was in the previous structure there was migration of lone pair of electrons, right? So this oxygen carries now positive charge. Fine. And the remaining part, that is the alcoholic group RO or what OR. Okay, that part I will be writing here O, then followed by what R. Fine. and the last step what happens, there will be loss of water hydrogen, okay, because initially we have added here water hydrogen. I hope you can see in the first step here, okay, in the presence of an acidic catalyst. So here what happens, this bond will be migrating to this water oxygen atom. So I can write it in this manner, right? So our product will be now R, then followed by C double bond O, then followed by OR, okay, that OR is coming from alcoholic group, and thus we have received our product, that is what ester. In this way mechanism esterification can be learnt. Now the second reaction under part B, okay, here there is a formation of acid chlorides, right? So when carboxylic acids are going to react with thionyl chloride, okay, thionyl chloride is SOCl2, or phosphorus pentachloride, or that of phosphorus trichloride, they give acid chlorides as major products. Let me first have an example with thionyl chloride, okay. So I'll be taking here acetic acid CH3 C double bond O OH, okay. So this is acetic acid. When this is treated with a thionyl chloride SOCl2, okay, then we are having our acid chloride. So that acid chloride is CH3 C double bond O, okay. Now students, this you have to remember, okay, this part, okay, now it is called as a group, okay, it is called as acetyl group, okay, remember always it is nothing but called as what, a acetyl group, right? So if I write here now as a Cl, so it becomes acetyl chloride, right, along with the formation of a side product, that is nothing but evolution of a sulfur dioxide along with the formation of acid, that is what, HCl. Now this is called as acetyl chloride. Now here we have generated an acid chloride by making use of water thionyl chloride. So let us have another example by taking phosphorus pentachloride, right? So I'll be taking here again acetic acid, and this is treated with PCl5, that is phosphorus pentachloride, and we will be having our product acetyl chloride CH3 C double bond OCl along with the formation of side product phosphorus oxytrichloride plus water HCl. So let us have another example by taking water benzoic acid, okay, that benzoic acid is C6 H5, then followed by C double bond O and OH, and then we are going to treat it with the phosphorus trichloride. So our product will be now C6 H5 C double bond O Cl along with the formation of a phosphorus acid H3 PO3. Now students, here Cl in the reactant side it is 3 times, but in the product side it is only 1 time. So therefore we have to write here 3 times, right? So therefore by writing 3 times, what happens, the aromatic part group that also should be balanced. So therefore I will be writing here what, 3 times, okay, 1 minute. So I'll be writing here 3 times, okay. But in this reactant benzoic acid there are 2 oxygens, so this is 1 oxygen and this is another oxygen. So 3 into 2, or so it becomes how many times, 6 times. So therefore on the product side here we are having 1 oxygen. I hope you are able to see this, okay. But this 1 into 3, it becomes how many times, 3 times, and here we are having what, 3 oxygen. So therefore oxygens are balanced, halogen atoms are balanced, and even the carbon atom is also what, balanced, right? So here the reactant molecule will be benzoic acid and our product will be benzoyl chloride. Now we are having the third reaction, right, and that is a formation of acidomates. Acidomates are having the formula R C double bond O and water NH2. One has to remember this. What is that formula? R C double bond O NH2, right? So carboxylic acids, when treated with ammonia, they are giving ammonium salts as intermediates, and these on heating a molecule of water is lost, and we will be having our product called as water acidamides. Let us have the general reaction. Okay, I'll be writing here GR, which is nothing but general reaction. So let me write the carboxylic acid R C double bond O, then followed by OH, when treated with ammonia. So one should remember ammonia as a base because it is having lone pair of electrons, right? And our acid is simply called as carboxylic acid. There is a formation of salt, and that salt is R C double bond O, then followed by O minus, then followed by NH4 plus. Now this is called as ammonium salt of carboxylic acid. And this intermediate on heating, what happens? It loses a molecule of water and gives our product that is acetamide RC double bond O NH2 plus H2O. Now we are having one example, right? And that example is taken by C6H5 C double bond O, then followed by OH, an aromatic carboxylic acid called as benzoic acid, and the same explanatory sentences. When treated with ammonia, we get corresponding ammonium salt of carboxylic acid. This intermediate on heating, it gives our acetamide along with the formation of water molecule, and this product is called as benzamide. Now let me have one CET point here. Okay, acetamides preparation. Okay, the best method for preparation of acetamide is by treating with acid chloride. Okay, acid chlorides are R C double bond OCl. Acid chlorides, when treated with ammonia molecule, we will be having acetamide. Okay, this is the most efficient method of preparation of acetamide, along with the formation of hydrochloric acid. In fact, it is one of the competitive question. Okay, how acid chlorides are converted into acetamide. Now we are going to learn the part C here. Okay, that is reactions due to carbonyl group of carboxylic acid. Okay, that is nothing but I'll write here C double bond O and OH. Okay, we have learnt that is A with respect to what hydrogen of carboxylic group. Then in the B we have learnt reactions because of what OH group, right? That was B, and now we are dealing with what only this carbonyl group, that is nothing but what C part, right? And here the only characteristic reaction of this carbonyl group is its reduction. Right, it means that it can be only converted into what a methylene group. Reduction is nothing but addition of hydrogen, right? So that C double bond O group is converted into CH2 group either by taking metal hydride, that is lithium aluminium anhydride, or with a hydrogen in the presence of copper chromate. Copper chromate is having the formula CuO CuCr2O4. So let us have the general reaction. So I'll be taking that carboxylic acid R C double bond O OH, right, and it is subjected to reduction by making use of lithium aluminium anhydride, or by making use of water hydrogen in the presence of that copper chromate. So we know that we are doing a reduction, and during reduction hydrogens are added to that carbonyl group. So what do we get here is that C double bond O group is converted into CH2 group. Fine. And that oxygen atom, okay, this oxygen atom, okay, this oxygen atom of carbonyl group is lost in the form of water, that is H2O. So all you can see that here two hydrogens are added to this carbon, and that oxygen of carbonyl group is going in the form of water, that is H2O. So altogether 4 hydrogens are added. So let me write it as here as 4 nascent hydrogen which are produced in the reaction, right? And what one can observe here, students, is that the carboxylic group, the carboxylic acids, when subjected to reduction, we can see that here the OH group is here and it is attached to this carbon, and this carbon is having what, 2 hydrogens. So therefore we are getting a primary alcohols, that we have to remember, right? So carboxylic acids, when subjected to reduction, the carbonyl group is converted into methylene group, and therefore one can find that the product is none other than primary alcohol. So let us take one example by taking acetic acid. Acetic acid when treated with lithium aluminum anhydride or that of copper chromate in the presence of hydrogen. Our product will be CH3, CH2 and what, OH, along with the formation of water, and our product name is ethanol. In a competitive part, I want to mention one statement here, that in the place of lithium aluminum anhydride or copper chromate, even we can make use of what, diborane, that is B2H6 in ether medium. Okay, even we can make use of water diborane in water ether medium. Apart from that, even we can make use of water hydrogen along with the catalyst called as water ruthenium. Fine. But these are with respect to competitive viewpoint, okay? But in case of NCERT textbook, it has been water lithium aluminum anhydride. So let us have one more example with respect to benzoic acid, okay? C6H5 C double bond O OH, and there are 4 nascent hydrogen, right? And the same reaction conditions, right? And we are having a primary alcohol, and the name of this alcohol is called as benzyl alcohol. Now it is part D here, okay? That is reactions due to carboxylic group as a whole, okay? I'll write here, okay, so that it will be much more easy for you. C double bond O, then followed by OH. We have learned first with respect to only hydrogen, second with respect to OH, third with respect to C double bond O, that is reduction, and now we are going to learn the whole part, okay, that is C double bond O OH. Is it clear, students? So therefore here what happens, carboxylic acids they undergo typically decarboxylation, okay, when that is sodium or potassium or calcium or ammonium salts, that is very important, ammonium salts of carboxylic acids on heating with soda lime. Soda lime is a mixture of calcium oxide and water sodium hydroxide. It is called a soda lime. It is commonly called as a decarboxylating agent also, right? And when it is treated with soda lime, we are getting hydrocarbons as our products. So let me have one example here, okay, and that example can be taken by sodium salt of carboxylic acid, particularly acetic acid, okay. So therefore O minus, then Na plus, it is commonly called as sodium acetate, okay. So we have to take a corresponding salt of carboxylic acids, right? When it is treated with soda lime, soda lime is a mixture of sodium hydroxide along with water, calcium oxide, right? We have to heat them, okay? So I'll mention here delta. We will be having our product that is nothing but called as what, hydrocarbon, methane, along with the formation of the salt, that is what, sodium carbonate, which is called as washing soda. The reaction heading, we can see that it is a decarboxylation. D means removal of water, carbon dioxide, so therefore we call it as water decarboxylation. So this C double bond O and O is lost in the form of water carbonate, okay, CO3 2 minus, okay. So if you take this in the ionic form, it becomes water Na plus, but it is monovalent, so therefore we have to write it as 2 times and this becomes carbonate, CO3 water 2 minus. In fact, if you see the structure of carbonate, it has been mentioned in this manner, okay, right? So this is called as water sodium carbonate. So let us have one more example. In fact, this example you people have to solve it, and I'll be writing here C6 H5 C double bond O minus along with water K plus, okay. The name of this reactant molecule is potassium benzoate, okay. So one has to see that here we are having a K, okay. So therefore our soda lime should be accompanied with water potassium hydroxide along with water calcium oxide, and then followed by what, heating. You try to write the products, right? Actually this part D is involving 2 reactions. So first one is decarboxylation. I forgot to write here, so I'll be writing here 1, right? And I'll be continuing with the next part, and that is coal base electrolysis, that is number 2. So coal base electrolysis. In coal base electrolysis, the condition of the reaction, let us try to understand. Aqueous solution of sodium or that of a potassium salt of carboxylic acids, okay. Aqueous, it means water should be there, fine. When subjected to electrolysis, electrolysis means we have to pass electric current into that aqueous solution of that corresponding salt of carboxylic acid. Then what happens, an hydrocarbon is liberated or water formed. I am saying that liberation, it means lower members of hydrocarbons are what, gases, right? Now let me write the dissociation of that salt of carboxylic acid, okay. So first reaction I'll be taking an example of sodium acetate, right? CH3 C double bond O minus then followed by Na plus, okay. So we are subjecting it to electrolysis. Then we are having the anionic part, CH3 C double bond O minus then followed by Na plus, right? So if I take 2 molecules, then I'll get here 2 molecules of acetate anion and 2 molecules of water sodium anion. Now let us take the dissociation of water molecule, right? H2O, again the electrolysis, right? And we will be having here anion, that is OH minus, and here also I'll write it as H plus. Now in order to understand this coal base electrolysis, so I have taken one beaker, and in that beaker there are 2 electrodes, okay. So this is one electrode here which is connected to the positive terminal of the battery, and this is the second electrode which is connected to the negative terminal of the battery, right? And electricity is passed, and in the beaker we have taken the sodium salt of carboxylic acid, which has ionized into acetate anion and sodium ion, and the water has dissociated into H plus and water OH minus. If you see carefully, there are 4 ions totally, okay, 2 anions and 2 water cations. Now when we pass electric current, then what happens? Anions are moving towards water anode and cations are moving towards water cathode, okay. So let me write it clearly. So this is called as cathode, right? Negative terminal is called as cathode, and the positive terminal is called as water anode, right? So positive terminal attracts water anions and the negative terminal attracts water cations, but both the cations cannot migrate towards cathode, neither both the anions can migrate towards water anode, okay. So that is what very important. Let us try to understand. Now at anode what happens, students? It has to attract anions. So there are two anions. Which are those? One is acetate anion and hydroxyl anion. So these ions are formed in the aqueous solution. But the electron releasing tendency, why I am saying it as electron releasing tendency, it means that these anions, okay, that is, I'll be encircling in the picture here, these two anions, they have to migrate towards what? Anode, right? When they have to migrate to the anode, anode is positively charged, right? So therefore they have to release electron there, right? So therefore we can see that the acetate anion is having a greater or a more tendency to release electron than that of OH minus anion. Hence acetate ion will be moving towards what? Anode. It means of the competition between acetate anion and hydroxyl anion, the one that gets towards anode is acetate anion. Now at anode we have to see how the reaction is forming. Okay, so let me take the acetate anion, that is by representing here CH3 C double bond O and O minus, right? When it moves towards anode, it has to give one electron, so therefore I will write minus E, that is E minus. Okay, it means it is losing one electron, right? But if you see the negative charge here, okay, so here I have written what is the negative charge. A negative charge is made up of how many electrons? 2 electrons, right? So therefore if one electron is lost, then we can say that there is a formation of a free radical. There is a formation of what? A free radical. So therefore I will write this as CH3 then C double bond O single bond O with one electron. Okay, in the form of dot I will write. Okay, because negative charge is converted into free radical. There is a loss of one electron which I have encircled here. Is it clear, students? Now this acetate free radical will be undergoing homolytic fission since it is highly unstable. Okay, homolytic fission means I can just write here the bond breaking. Okay, the fragments formed will be containing a same number of electrons. So therefore this one fragment will be forming one odd electron here, and this one fragment will be forming an odd electron here. So this free radical will be forming an bond between here. So altogether now I can write here as it leads to the formation of a methyl free radical plus along with the evolution of what? CO2, because we know that we are learning about decarboxylation, right? Now the question arises how this methyl group is converted into hydrocarbon, right? So therefore if I take two molecules of acetate anion, then there will be a loss of what? 2 electrons, and it leads to the formation of two molecules of acetate free radical, and there will be the formation of 2 moles of methyl free radical and 2 molecules of carbon dioxide. Now this 2 moles of methyl free radical will combine in a systematic manner. So this is one methyl free radical and this is another methyl free radical. Both will form a bond between these two carbon atoms. Thus we can say that there is a formation of a ethane molecule, and that could be simply returned here. I'll be erasing this part so that it becomes much more simplifier manner, right? So I'll write here as ethane molecule, that is CH3 single bond CH3. Fine, students. So this is how ethane is formed at anode. Remember, always hydrocarbon gas is liberated at what? Anode, right? Now let us see what happens at cathode. Now at cathode we are having both Na plus as well as H plus are present in aqueous solution, right? But the thing we should remember that sodium has already lost one electron and it has become stable. Okay, this is an electropositive element, sodium, right? So after losing one electron, it acquires a nearest noble gas configuration. So therefore what do we say? That the latter one, the latter is nothing but here I mean it as what? H plus. Former in the sense I mean it as what? Na plus. So therefore the latter, which is having a lesser discharge potential, right? which is having lesser discharge potential, will be liberated as water H2, that is hydrogen gas, and sodium ions remain in the solution. So at cathode the simple reaction takes place, that is 2H plus will be moving towards cathode, and at cathode what happens, they are gaining 2 electrons. With the gain of 2 electrons, what is liberated? Hydrogen gas is liberated, right? But what remains in the solution? In the solution there remains of Na plus and OH minus ion. Thus we can say that the coal base electrolysis medium after electrolysis is what? Basic in nature, right? And the limitation of coal base electrolysis is that methane cannot be prepared by this method. This is the first limitation. And the second limitation is only alkenes with even number of carbon atoms can be obtained by this coal base electrolysis method. Is it clear, students? Thank you for watching this video. If you feel good, kindly like the video, share the video, and also subscribe to my channel. Thank you for watching.